Yep, you can see my screen now, Jitesh, right? I'm sorry, you can unmute yourself. Sorry, because I muted you already. Can you see my screen now?
Yes, I can see David.
Ah, nice. Okay, okay, okay.
Let me know, and I'll mute. I'll go mute now.
Yeah,
So
no,
there you
well,
go.
yeah, thanks. Okay, so welcome to today's Azure Hangout. So today we'll be talking about Azure Standard Load Balancer, and it's all about looking at this Azure resource from different perspectives and try to cover it from an holistic point of view. So we try to look at the overview of this Azure resource, and then we'll cover things like what limitations does it have? How do we implement it, or how does it operate? What about monitoring? If we want to do some monitoring on the resource, what are the options available to us? Then we'll talk about also about architecture guidance, talking about the scale, options, availability, performance, security, support, and SLA. In other words, just covering this resource from different angles. And hopefully at the end of this, we'll come out with a better understanding of what Azure standard load balances, how they operate and what they are, and how we can implement them in a different architecture design. So my name is David Okiode. I'm a cloud solutions or security architect. I'm a Microsoft trainer. I'm triple MCSE. I work with cloud technologies every day. Let's move on. So let's start by covering, or let's start by talking about um, the load balancer that we're talking about today, the standard load balancer. Why in the world do we even need a new load balancer? So those of us that are already familiar with Azure may know that there are different load balancing options in Azure already. So for example, we have what is called the Azure Load Balancer. So it used to be called the Azure Load Balancer. It's called the Basic Load Balancer now. It used to be called the Azure Load Balancer. Layer 4, um, Layer 3 load balancing and distributing traffic to different endpoints. Um, Within a region, if you have VMs or if you have VMs in an availability set, it can distribute traffic to those. Then we have something called the application gateway, which if you want, and something that can take off some of the load from your application. So things like SSL termination, and you can integrate with some level of WAF, not as advanced as other form of WAF solutions out there, but some level of WAF built into that. You can go for the application load balancing. And then if you're doing some form of globally distributed application, so using something like the Azure Traffic Manager, which is DNS based to route traffic across different Azure regions, or even your on-premises data centers. So having all these options, why in the world would we need another one? Because Microsoft just came out with this, and we'll see what the timeline is for this new resource. Let's get to that. So to begin with, I think it's important to understand where Azure Resiliency is today. Well, not today. So this was before. So actually, that slide needs to be updated to say Azure Resiliency in the past. So in the past, Azure Resiliency, we had three levels that we can operate with. So we have this thing called Azure Regions. Um, and in Azure regions, we can deploy our services into that region. So Azure region is essentially multiple data centers that have been coupled together to operate as a logical data center. So multiple physical data centers that are working together similarly as a logical data center. And we can deploy our services into these data centers. And we have to be careful because at the end of the day, we're still dealing with racks, we're still dealing with physical hardware kits like network appliances, top of the rack, network switches and storage and all the other stuff and computers. And we have to be careful to ensure that our services that we've designed to give us resiliency don't end up on the same set of hardware. And then if there are failures, which there will be failures, if you have hardware of any sort, there will be failures. Our drives will fail, things will crash. So, and if there are failures, to ensure that all our services or all our service endpoints don't end up on the same node. So Microsoft give us something called Azure Availability Set. So we can put our resources in our services in availability set, and that will ensure that they don't end up on the same hardware. So that protects us against hardware failures within a data center or within a region. Then we had disaster recovery. So what happens if the entire region that you've deployed your Azure service to gets wiped out? You can do something like Azure Disaster Recovery and mirror your application across to a different region. So in Azure, there's this concept of Azure paired region, so Azure region pairs. And region pairs, they're great. They're great for this. Yeah. So one of the issues that we have with Azure paired regions is the latency, right? So typically Microsoft will say that they prefer for these regions to be about 300 miles apart. So it's not always 300 miles apart, or at least 300 miles apart. So it's not always like that in every situation, but that's Microsoft preference. That's what they're trying to design to. And there's a good reason for that, because for certain level of failures, where you're talking about hurricanes or natural disaster or political instability, that could cover a whole region very quickly. So they had to ensure that there's a lot of separation across this region pairs to try as much as possible to ensure that a failure or a disaster in one region typically should not affect the other. That's not like all the way guaranteed, but that's possible. So that's disaster recovery. And we can also use those paired regions for backup. But as we mentioned, the main issue is when you have services or applications that needs to be coupled together closely, but you still want resiliency at the data center layer. So if a whole data center fails, you still want your application to carry on functioning. But then the other issue is the regions, paired regions are too far apart for your requirements. So if you're trying to do something like synchronous replication, if you're trying to do that over a paired region over at least 300 miles, there's a speed of light limitation, there will be latency, which may not meet your requirements. You may be thinking, but all this sounds really good. We've got all these different options for load balancing. We have all these different options for resiliency in Azure, or we had these options for resiliency in Azure. What's wrong with this, which we'll talk about very soon, or we talked about some of those, but we'll talk about that some more. So then the other thing is the load balancing scenarios that I mentioned earlier, where we had things like a load balancer to load balance within a region, within our availability sets. So that's good. Then we have, let's hide this. Then we have our application gateway that can provide layer 7 type load distribution, SSL termination, HTTP for HTTPS type traffic. I think it also covers WebSockets. So that's good. And we have Azure Traffic Manager, which we can use for global distribution. So what Microsoft has now done, and this announcement essentially came out just around, I think it came out around October last year. Microsoft came out and announced and said we're adding a new concept called availability zones into Azure regions. In other words, when you talk about an Azure region, it's not just a bunch of physical data centers that operate as a logical data center. Now we actually have separate data centers that you can choose which data center in a region to deploy your services or resources into, so which is called the availability zones. So this is one of the reasons why we need the new load balancer. It's not the only reason, but I'm just trying to lay some groundwork to show one of the reasons why we need this. Because if we go back a slide, this load balancer cannot operate across availability zones. It can only operate within a particular availability zone, and it's limited to an availability set. But in this case, now where we have multiple availability zones, we probably need a different or a new type of data set, load balancer that will be able to accommodate that. So that if we're designing our solutions and splitting them across multiple availability zones, we can distribute loads across all our services, across all the different availability zones that we're using. And that's where the standard load balancer comes in. So one of the things that it gives to us is it gives this thing called zone redundant load balancing. In other words, you can see in this picture here, you can have your service deployed in zone 1 across zone 1, zone 2, and zone 3 of a particular region. But at the same time, you have this standard load balancer that is aware of that and can distribute the load that's coming in or going out, whichever way you're using it, can distribute that load across multiple zones and your services across multiple zones. So that's one of the reasons. That's not the only reason, but that's one of the reasons why we need these new ones. And this will help us as we go on. This will help us to understand um, why standard load balancer are so much tightly coupled with availability zones and all the other announcements that Microsoft has made in the past 5, 6 months. So let's move on here. Another thing that used to be an issue in the past is this thing called network virtual appliance resiliency. So where you're using network virtual appliance solution like a next-gen firewall, something like Sophos, you're using WAF appliance or whatever appliance that you're using. So it used to be in the past that it's very difficult to use more than one of these. Best practice is to use more than one. It's very difficult. And usually you're limited to an active passive situation. So what you need to do, what we usually had to do in the past, is we'll have uh, an active network virtual appliance and a passive network virtual appliance. And then we'll point our route table to the active network virtual appliance. And then we'll have this bunch of zookeeper cluster. So I set this up in the past. Believe me, it's very complicated, extremely complicated. We have this set of zookeeper cluster and they're running in containers and they're doing some monitoring to the network virtual appliances that we've deployed. And then if they detect a failure, the zookeeper nodes are going to make an API call to the Azure Fabric and modify the route table to say, I've detected a failure, let's point to the passive one now. But again, one of the things that this new standard load balancer brings to us is something called HA ports. Okay, actually, if I go back to this one. So apart from this complicated method of achieving resiliency, right? One of the other things is if you wanted to load balance across multiple ports, with the old load balancer that we had, or with the former one, you had to do it port by port. So I want to load balance across port 80, no problems. I configure port 80. Okay, yeah, port 81, let's configure port 81. Now, if you imagine when you're talking about a network virtual appliance where it could be any port, and you want to load balance across 65,535 ports, however, that can be something really difficult to achieve or to accomplish. So the new standard load balancer brings this thing called HA ports that just makes it easier. All we need to do is set up this new standard load balancer and configure a network virtual appliance nodes as the backend pool. And with a single tick, which you see, with a single tick, we can configure HA port. And what that will mean is going to load balance every port, as you can see here, from port 1 to port 65535. It's going to load balance all the ports across the MVA pool. This not only covers that, but it also improves upon the limitation that we had with the Zookeeper cluster. And now we can have active. So these are some of the reasons why we have this new standard load balancer. But as we go on, we'll see some of the other functionalities and features that it brings to us. But let's move on now. So here's a brief timeline of the Azure load balancer. So in in May 2014, Microsoft announced the preview of something called the internal load balancer. That was the days of the classic Azure. And then in July 2014, that internal load balancer became GA. It had certain features built into that. Um, in January 2016, they released integration with log analytics to allow some form of monitoring and analytics with this Azure load balancer. And that came in preview then. But much more recently, you see Microsoft has been ramping up the development when it comes to this. So September last year, for example, they announced this new Azure Standard Load Balancer. So they announced the preview of that. So it went preview in a few regions. And then remember that we talked about one of the things that it provides is this integration with availability zones. So it came at the same time range when they announced the preview for Azure availability zones, where we could have multiple data centers that we could select, and with the physical or logical data centers that we could select in Azure regions. And they announced the preview of that in October last year. And January this year, they announced another feature called Zone Redundant VM Skill Set. So all these are gearing together. So we'll talk about some of this. All these are gearing together to talk about a new way of architecting resiliency in Azure. So standard load balancer, when you think about it, you're thinking about it in the context of standard load balancer, availability zones, zone redundant VM skill sets, not the other features like that. So those were when the previews were announced. Um, in March 2018, which was just last month, Microsoft finally announced the Azure Standard Load Balancer is going GA. So this is just something that was just by a month ago that this became GA. And also for availability zones, they announced the GA of availability zones in Central US and France Central, and that was in March and March last month also. And then they announced they extended the preview to cover East US, West Europe, Southeast Asia, and the other. So that's where we currently at. If you notice that the last one, um, zone redundant VM skill sets, it's not yet been GA'd in any region yet, but I'm sure that we'll get there very soon. So this new load balancer, let's just run through quickly and then we'll cover some of these in details. What are some of the advantages that it brings to us, or what some of the main differences that we have with this new load balancer? And also, by the way, before moving on, to mention that the thing that we used to call the Azure load balancer in the past has now been changed to Azure basic load balancer. So this new load balancer, it's a new SKU, load balancer in Azure. One of the benefits that we have is that it can pull up to 1,000 instances. That's huge. That's times 10 of the old basic one. The old basic one, you can go up to 100 instances, and you're limited to an availability set within an availability zone. This one you can spread across availability zones, but you can go up to 1,000 instances. You can use multiple virtual machine skill sets. We'll talk about this in details. You can do zone redundant data paths with a single IP. In other words, you have your standard load balancer, you have your services across different zones, and you don't need to be worried about, oh, what if this data center were to fail? What happens to my standard load balancer? It's redundant across all the different zones. So it's zone redundant itself with its data path. We have zonal front end. So if you wanted to, you could also put a standard load balancer within a zone, make it have a zone front end. We have cross-zone load balancing. We have HA ports for MVAs, like what we mentioned. Then we have advanced analytics, the type that we didn't have before with the old one. So we get into some of this. So let's move on a bit now. Let's talk about the functionality and the operation of this new standard load balancer. So one of the first things that we have to understand is that this is part of the Azure software-defined networking stack. In other words, or not in other words, one of the things to know is that this is a fully managed resource in Azure. So it's not one that we log into, that we create or manage anything. It's one that's fully managed. And all we need to do is to provide our configuration. We don't do any management or any infrastructure like that. The other thing to also know is that this is a multi-tenant platform. This is not a dedicated appliance, because sometimes we hear load balancer, we can think, oh, Microsoft is giving us a dedicated software or hardware appliance or whatever that we can run and use that to load balance. No, this is essentially, remember, it's software-defined networking, and this is a multi-tenant platform. In other words, there's these distributed nodes that are already present, of infrastructure that are already present in Azure. All we need to do is provide a configuration which will program the nodes with the instructions that we provided in our configuration, and then load balancing begins to work. So it's important to know that. So it's high performance and low latency. We'll talk about that when we get on the performance. It's flow based. And one of the things to note is that the load balancer itself does not terminate the flow. The flow just goes through the load balancer. The termination occurs at our endpoint. So whatever endpoints that we've configured for it to distribute loads to, that's the communication is always going between the source and the endpoint destination. The load balancer doesn't in any way terminate the flow in the middle. In other words, if you're doing a TCP three-way handshake, load balancer doesn't get involved with that. It just forwards the flow. We have health probing, which we'll look at some of that. It has inbound NAT rules. We have outbound connections. We'll look at some of that. So the three fundamental scenarios that this load balancer covers is we can use it as public-facing load balancer. In other words, we have our services internally that we want to make available to the public. We can use the load balancer for that scenario. We can use as an internal load balancer. In other words, it's not internet facing, it's not public facing, it's just within our own virtual network, but we can point to that and then it distributes load to loads within our virtual network, but it's not available publicly. But then it can also fulfill a task for outbound connections. We'll look at this a little bit. We'll actually do a demo on that, I think. So some more information about this. Some of this we covered already, but just to reinforce the knowledge, um, is that Azure Standard Load Balancer can cover resources, virtual machine skill set across our VNet. So the limitation is no longer availability set like we have with the basic load balancer, where we had to specify VMs within an availability set and then it's limited within the availability set. In this, you can have multiple availability sets, it does not matter. You can have multiple VM skill sets, it does not matter. You can have multiple VMs in availability sets, it does not matter. So that's not the limitation anymore. Again, it can go up to 1,000 instances rather than up to 100 instances in the case of basic load balancer. There are a bit of caveats that we'll talk about when we get to look about this in more details. This is a deep dive presentation. HA ports is another thing where we can balance and scale virtual appliances, which we'll look about, and then we'll look at that a bit more. And then we have the advanced analytics, which we'll also cover within the section for monitoring and analytics. So when it comes to availability zones, one of the main things to note is that this is again zone redundant. So what does that look like? So look at this. What that means is, for example, if you deploy this standard load balancer and you specify that you want it to be zone redundant, it's going to create an anycast address, which essentially means that it's some programming that's going in the backend, some complex programming going in the backend by Microsoft, which will create a zone redundant data path across all the different zones that you have. And this is something that will be replicated across all the different zones so that it does not matter if this entire zone goes down, it does not matter, your standard load balancer will carry on functioning. In other words, your standard load balancer will always function as long as there's a zone that's available. The only time that it's going to stop functioning is if something happens and all the zones were to go down completely. But as long as the zones are active, this is replicated programmatically across the zones and it will carry on forwarding traffic. And this works not only for public load balancers, but for internal ones also. And it not only works just for inbound scenario, it works for outbound scenarios also. Okay, moving on. So we mentioned this is a new one. We talked about this when we were looking at the timeline. So this is a new feature that's currently in preview that hopefully will GA very soon. So standard load balancer, you can have your VM scale sets across different zones at the moment. But what's coming is you'll be able to create a single VM scale set that's going to cover all the three zones. So instead of you having to create a VM scale set and specify this is for zone 1, VM scale set for zone 2, VM scale set for zone 3, and then point your standard load balancer to distribute load to all the three. Rather than doing that, you just create a single resource, which is zone redundant VM scale set, and specify I want you to distribute the VMs across zone 1, zone 2, and zone 3 and make them equal across all the three zones. And just a single resource, it covers all that. Standard load balancer distributing traffic to that. So that's something that we will see at some point. We'll talk about this requirement for network security group at some point. So again, we've covered this in the past, so I'll just skip on about network virtual appliances and the benefits that we have with this new standard load balancer. So let's talk a little bit about how health probing works in the standard load balancer. So health probing is how the load balancer knows that our instances, our backend instances are healthy. If the load balancer detects that it's healthy, it's going to send traffic to them and distribute loads to them according to its algorithm. So it uses a 5 tuple, which is the source IP, destination IP, source port, destination port, and protocol. It uses that to calculate and hash. We can specify that depending on the level of stickiness that we want. Then it's going to distribute this load across all the VMs that we have. but it's going to keep monitoring the health of the VM. And we as administrator will specify um, how, what to monitor, what to look at. So one of the options that we have is we have the TCP health probe, which is just going to be doing a TCP check. It's going to send a TCP packet to the host on whatever port that you specify. As long as it gets a response back, it's going to go that host is LD. I'll keep forwarding traffic to it. If it sends a probe to it, and then depending on your configuration, if it does not reply, you can configure that. So it's not limited to that. So you can configure that. If it does not reply, it's going to go, this host is no longer available. I'll stop forwarding traffic to it. But the issue with TCP health probe, of course, is that um, it may not take into consideration whether your application is actually functional or not, because it's just doing a check off. I've done a TCP connection, I get a reply, does not mean the application is actually functioning. So we have another option, which is the HTTP health probe, especially if you're doing for HTTP type services, where we can specify and say, I want you to probe this path on this server, the specific path. So you can put in an HTTP path, and then it's going to probe that. And it's only going to report back and say that node is LD as long as there's an HTTP 200 reply. If there's not an HTTP 200 reply, it's going to take that node out of the available nodes. And what that means also is that for us, we can configure our machines or our service in such a way that if certain conditions are going on the machine, it's going to reply back, not with HTTP 200, but a different reply so that the load balancer can take it out of the available pool. But those are the diff2 options that we have. And we'll see some of those afterwards. Actually, let's do a quick demo and look at this because we've been talking for a while now. Let's go over and let's bring up Azure. So what I'll do here is I'll go over to the Azure portal. If I go to load balancers, I can see the current load balancers that I have available. I can go ahead and add a new one. So in this case, I can say tests. By the way, let me expand this a bit to make it easy for you to see. Okay, so let's call this tests public load balancer 2. I've actually created one already. That's the one I'm going to use just to show the options that we have when we're creating this. So we can specify if it's public, that means it's going to be internet facing and it's going to have a public IP address. And you can see if I select public, I have the option to specify the IP address that this load balancer will have. If I specify internal, it's going to change that from IP address to virtual network. I have to specify the virtual network I want to deploy this into. But now you see this new option for the SKU. So where I can specify either basic or standard. If I specify standard, one of the things that we'll see is that if I go to create an IP address that's going to be associated with it, it's selected standard and it's locked it down to standards. So I have to use a standard public IP address if I'm using a standard load balancer, and I can't mix and match. I can't use a basic IP address. Standard IP address essentially means an IP address that can be available across all the zones in the region. An IP address that's not limited to a single zone. So if I go ahead and specify and say the name of this will be, let's say, what's the name of the load balancer? I called it that. I'll copy that and I'll just put PIP at the end. And here I can specify if I want this IP address to be specifically tied to a zone. So if I wanted to, I could tie it to a zone or give it a zonal front end. And there are different reasons why I may want to do that. Or if I just want to use it to put loads across multiple zones, I can just specify zone redundant. And if I click OK, I'm going to use that IP address. Specify resource group for it as always. Remember that in case you're doing this in a lab environment and you want to be able to use standard load balancers with availability zones or with zone redundant VM scale set, remember that you have to select the region where either those services have been GA'd or either where they are in public preview. So in this case, I think the ones availability zones have been GA'd in Central US and France Central, I think. So, but it's in preview in West Europe and some of the other regions, about 3 other regions. But for now, I'll just select Central US. And if I click on create, so it's as simple as that when we're creating a virtual machine, um, when we're creating load balancer, standard load balancer in Azure. So once it's created, like in the case of this one that I have running, you can see the SKU here says standard. Yeah, and also when we go to define our backend pool, we can define pools, we can define backend resources that are located in any of the zones that we want to, and we're not limited by availability set, like we did. With the health probe that I talked about earlier, with the health probe is where we can add a probe and say where we're going to be probing from. Are we going to be probing from, or we're going to be probing for, sorry. Which port are we going to be checking? Are we going to be just doing TCP or HTTP? If we specify HTTP, now we can specify a particular path on that web server to say we want to look at this path. And we can specify the interval of the probe. Do I want to check every 5 seconds, which is the default? And I think that's probably the minimum that I can go. I think if I try to specify 4, it's going to say it must be between 5 and this number. So the minimum I can go is 5. And then the threshold, I think the minimum I can go is 2 also. If I try to specify 1, I think it's going to complain and say you have between 2 and this number. So that's the default. So the minimum is what we have as the default. I can specify whatever I want it to probe and give it a name. And then it's going to start to look for that. So one of the things that I also want to mention is where the source of the probe will come from, because this one can confuse a few people. Especially, it can be very confusing if you're using an internal load balancer. And when you're using an internal load balancer, it can be very confusing. What's the source where this probe is coming from? Remember that this is a multi-tenant service. This probe is actually coming from a specific IP address in Azure. So it's important to know that. So for example, if I go bring up my service here, and let's restart my session. Let's log into this. I think I'll actually expand this to make it much easier for you to see. Let's go change settings, and let's change this to 20. That would do. Let's make it bold. Yeah, that would do. So using this, for example, if I go and let's log into one of our backend servers in this case. Okay, if I do TCP dump any host. So this is very important. So if I do, let's do this, Azure load balancer. So it's very important to remember this. It's a very, very important thing to know what the source is coming from. So if I go here, you can see a load balancer probe in Azure uses the IP address of 168.63.129.16, and that's both for standard and basic. This public IP facilitates communication. It's not something that we can change. It does not change. So it's important to know that that's the IP address, because if you're doing any form of network security group and you're blocking things, you have to be aware of that. Let's do a sudo first, and then let's run our TCP dump again. And you can see our probe coming in on that IP address, 168.63.129.16. That's where that probe is coming from. So it's important to know that. So in case we are creating our virtual machines, actually, let's go under network security groups in this case. If I have network security group up here, okay, let's go for all services. And let's look for network security groups. If I'm creating my network security group and I create a fresh network security group, one of the default options that we'll have is we'll have this default rule. right? It's not a rule that I've manually created. It has a default rule that says allow Azure Load Balancer protocol any source. It's a tag called Azure Load Balancer and destination is any. This is a default rule. Of course, because it's a default rule, you as an admin can override it. What this source translates to the IP address that we looked for now, which is this IP address 168.63.129.16. If for some reason we decide to override this and we don't have an explicit rule that allows the IP address, our health probe will fail. Because don't assume that because it's an internal load balancer and it has an internal IP address, that's where the source was, that's where the probe is coming from. The probe is not coming from there. The probe is coming from the 168 address. So it's very important to note that. Okay, that being said, now let's move on to some of the rest of the stuff. So again, if we wanted to deploy this, so actually 1 minute, let's make sure that, okay, yeah. So if you wanted to deploy this, it's actually relatively straightforward. If you're using, if we're using the Azure Ham template, what we need to do is we need to ensure that we have the right API version specified in our Ham template for the resource. So we specify the API version in the section for the resource. And then the main thing that we're changing here is just the SKU. If you look at this, it's essentially the same format, the same syntax. The only difference is now we have a new section called SKU that we can specify basic or standard. If we don't specify any, it's going to default to basic, I think. So that's all we're doing is they've just added a new option to specify the SKU. And remember that we must use this a matching SKUs for load balancer and public IP. If we're using a standard load balancer and it's a public load balancer, then the IP address has to be standard public IP. If we're using, even if we want to give it a zonal front end, it still has to be a standard load balance, standard public IP. If we're using basic, we have to use basic IP address also. Okay, moving on. Now let's start talking about this particular resource from different angles. So let's start first talking about in terms of scalability. How scalable is this resource that we have? We mentioned that it's multi-tenant, it's fully managed by Microsoft. All we do is we provide our configuration. We're not actually doing any management whatsoever when it comes to this. We're just providing our configuration to the Microsoft multi-tenant node and it's distributed, and that's going to apply that programmatically. In terms of scalability, remember it's fully managed service, so Microsoft handles the capacity. So it's not up to you to determine, yeah, maybe we need to add more capacity to this. No. So that's handled by Microsoft. And it's one of the things that I'll actually show you in one of the slides. I think actually, let's go. So if you look at this one, I'll come to this obviously. But if you look at the last quote here, creating a load balancer doesn't create an instance because again, remember that it's multi-tenant, the infrastructure already exists and capacity is always available. So that's from Microsoft document saying, listen, we have capacity always available when it comes to this. So backend pool scale, we can scale up to 1000 as we've mentioned. There are a few things to note when it comes to this. So even though we say here we can scale up to 1000 backend pool, there are some caveats to that. So for example, if you're configuring a virtual machine scale set, if you want your virtual machine scale set to scale up to 1000 instances, there are certain things that you must do. So for example, you must use the managed disk. If you're using unmanaged disks, you cannot scale up to 1000 instances in a virtual machine scale set. You can only scale up to, I think, 300 instances. Is it? Maybe 100. I'm not sure. I can look that up. Yeah. So just remember that. The other thing that you have to do if you're using a virtual machine scale set is if you're using a custom image, an image that you've brought in yourself and you've installed the Azure drivers on it, you can only scale up to 300 virtual machines. You can scale up to 1000. So if you're using an Azure Marketplace image, you can scale up to 1000. So it's important to know that even though you can scale up to 1000, you could be limited based on whatever image that you're using for your VMSS or whatever this type that you're using for this. So it's important to read the documentations for these also. They affect the scalability of the standard load balancer. Also, this is also important when it comes to increased outbound connectivity. This is also a very important one. So what many people don't know, and this is where the demo actually comes in, is that whenever you associate a standard load balancer with an Azure Virtual Machine Network interface, that public IP address that's associated with that public load balancer begins to be the IP address for that virtual machine. This will make sense. I want to show you. So one of the things I want to do here is, let's go back because we'll do some quick demo here. Let's go back to the Azure portal. And within the Azure portal, I already have two virtual machines. Essentially, let's bring up a diagram here. What I currently have, or what I have is I have just two virtual machines. Very, very simple topology. Nothing complex at all. So two virtual machines that I have the Azure Load Balancer, which I'll get now. Azure Load Balancer. Yeah, this will do. Let's copy this image. Let's got ourselves an image for a load balancer. Okay, we have an Azure Load Balancer in front, and that's load balancing between these two. Oh, that's not the plan. So we do the first one and then it's load balancing to the second one. And the names of my virtual machines are also very simple. I have web server 1 and I have web server 2. Just these two. So one of the things that this load balancer, let's say I have a public IP address associated with it. And I have a load balancing rule configured to load balance traffic across these two. What that means is that any traffic that's now going outbound from my virtual machines would take on the IP address that's associated with the load balancer outbound. So that's what they're going to take on. You say, what? You say, yeah, I know about that already. Because what happens is if I have a virtual machine that's not associated with a load balancer like this, it's going to take on an IP address that's randomly given to it on the Azure Fabric, or if I associate a public IP with that, it's going to take that on. But if I don't, or if I associate it with a standard load balancer, it's going to take on that public IP address, and that's actually how its outbound connection is going to work. There's a whole complicated topic. There's a not complicated. It's a comprehensive topic by itself, how outbound connections work in Azure, which I won't go into too much details, but I'll just do a brief demonstration to show. So what I'll do is if I go on one of my virtual machines, in this case, I'll go to, actually, let's go on to the load balancer first that I have running, and I'll remove all the configuration that I have for my backend pool. So if I go ahead and delete that backend pool. So if I need to delete the, I need to delete the out probe first of all. So let's delete the, I think actually let's start from the load balance rule. I'll delete the load balancing rule first. And once that's deleted, I'll delete the out probe and then I'll delete the backend pool. Okay, it's gone. Let's get rid of the probe. And then we'll reconfigure all of them again. So I can show us what happens without it. Okay, now finally should be able to get rid of this now. Delete, delete, yeah. Okay, yeah, so that's gone now. Okay, so what I'll do is I'm currently on web server 2 at the moment, which is the one I'm logged into. I'll clear the screen. And what I'll do is I'll check the public IP address that this machine is using. something going. It's essentially doing what's my IP on Windows. That's what I'm trying to do on this, but I'm on a Linux machine. That's where I'm doing that from. Now, because I just made some changes, it may take a while for that to apply, but hopefully that will give me a result very soon. While that's thinking about it, I'll just log into the second virtual machine, which is VM1 or Web Server 1. And let's log into this. And I'll do so this is outbound traffic. Let's try another one. Let's make sure that we're good first of all. So that doesn't look like it's working. So what we'll probably do, I think it may be down to, which we'll also talk about and we'll do a demonstration of, maybe down to network security group. So let's go add the network security group to our appliance first of all. So network interface, and now associate the network interfaces with that network security group. Just make sure that we're all good. Okay, that's saved. Let's associate the other one. So that's Web Server 1 and Web Server 2. We're associating them with the network security group. And by the way, if you notice, web security groups can take a while to apply. So sometimes when we see on the screen and it says successful, sometimes what that means is I've successfully submitted a job. Sometimes it does not mean that I've successfully applied when you want me to apply. So it may not mean that at all. Let's see. Oh, maybe I can use another one. I'm already logged into this one. What I'll do is I'll exit this and I'll just use the machine I'm logged into. No, I won't be able to use that. Okay, I think what I'll do is I'll probably move on because of time, so as not to waste time with this. But what we'll have seen, if that worked, it will be once we associate a public IP, or sorry, once we associate a machine with a load balancer, it takes on the IP address of that load balancer for outbound connections. And what we now need to be really careful about is because all these machines are now sharing this single public IP, if we have only a single one, is we need to be able to be careful about the source NAT or the port exhaustion of this IP address. Because this IP address only has so much ephemeral ports that it can use. So let's say we have this load balancer associated with 1,000 VMs, which you can have up to 1,000 VMs in the backend. And they are all sharing this IP address. Would this IP address be sufficient to do port address translation for all the 1,000 instances, for all the outbound connectivity, for the flows that they are doing outbound? Will it be sufficient? We need to be careful of that because it's important to know that they're using this IP address. And essentially what it's going to do is it's going to distribute the ports that are available, is going to distribute it across the virtual machines. There's actually a table on Microsoft's website that covers this. It's very, very, very interesting thing to read about. So if you look at this table right here, if we have about 1 to 50 VMs, every VM will have 1024 ports that it can use from the IP configuration. If we have 51. If we have 1,801 to 1,000 VMs in the backend pool of the load balancer, they all get 32 ports each. That's the amount of ports. So that we better make those calculations when we're thinking about scalability. Those have to be part of what we're thinking about in terms of, because we take on this IP address for outbound connection now, or this the amount of ports that will be available depending on the pool size of the backend, would this be enough for the machines that we have? So it's important to calculate that, and that's like the main area where you have to think about when you're talking about scale of this Azure standard load balancer. One of the things that we can do to alleviate that is we can have multiple IP address or multiple front-end IP addresses associated. So for example, if I had another IP address, another public IP address to that load balancer, now I have two that I can use. So in this case, every VM, instead of getting 32, we get 64. So let's say I had another IP address, rather than getting 64, they will get 32 times 3, and then on and on. So we can add multiple IP address to increase the pool if we wanted to, but it's important to note that that's the behavior. Let's move on now with this. Okay, availability. Let's look at this from the standpoint of availability. What do we need to do anything to make this highly available? Eh, When talking about availability, um, it's zone redundant, right? We're using this to provide availability. Microsoft looks after and ensures that it's highly available. Again, remember, it's a fully managed service. It uses distributed mode because, again, remember, we don't have an actual dedicated instances. This bunch of nodes that are looked after by Microsoft. It's a multi-tenant infrastructure, and Microsoft has said the capacity will always be available. So when it comes to availability, that's highly really looked after by Microsoft. Apart from you looking after the availability of your backend instances, like if you're pointing this to virtual machines, you have to take on the responsibility of ensuring that you've configured your probes correctly to probe the right port that you're actually listening on in the backend. So apart from that, the availability of the standard load balancer itself is mainly on the side of Microsoft because it's a fully managed service. In terms of performance, we don't actually get numbers from Microsoft when it comes to the performance, but what they do say is that it's low latency and high throughput, and it can scale up to millions of flows for TCP and UDP applications. So they have this highly available, low latency, high throughput infrastructure setup that's automated and that doing the load balancing across multiple nodes for multiple users. So it's important to just note that. Traffic goes through the Azure backbone, which is very high speed. So it's not transferring over anything beyond Azure. When talking about performance, is actually one of the advantages of this standard load balancer versus the basic load balancer is that this new load balancer actually operates on a brand new control plane in Azure. And what that means is that it's faster to deploy. It's faster when you're doing management operations, when you're making API calls. According to Microsoft, if you're making management operation calls for the standard load balancer, it will typically be less than 30 seconds. And I think I did a bit of test with this. And actually, that's if I'm doing a deployment, it usually takes between 17 to 19 seconds to deploy a new. I just did one just now, and just took a few seconds to do. So, which is not as fast if you're doing the basic load balancer because this is actually operating on a new control plane. So it actually gives some performance benefit when it comes to that. Again, in terms of the actual performance between this and your backend instances, just know it's low latency and high throughput, but there's no numbers that I've found anywhere online for that. When it comes to security, because you may be concerned that now my traffic is going through this middle plane that's fully managed by Microsoft, how does that impact on my security? Will Microsoft start snooping my traffic or whatever? If you're really concerned about that, one of the things to note is that the flows that are going through the load balancer or this distributed architecture does not actually terminate on the architecture. They terminate at your endpoint. They just flow through that. It is different if you're using something like application gateway. But the traffic flows through that and terminate at your endpoint. But the other thing is that if you're really, really concerned about that, which you're right to be if you are, Just ensure that your applications that you've implemented, you have application level protection mechanisms like TLS or encryption mechanisms enabled for your applications, for inbound and outbound flows. So that's probably the way for you. That's what you can control. You can really control what's going on within this load balancer, but just to know that things don't get terminated there, things just flow through the air to your backend. Jitesh says, do we do set anything up for? Sorry, I just saw the question, Jitesh. But I actually get to the question at the end, actually. So I'll get to the questions, no problems. So, what about if you're concerned about distributed denial of service? Again, remember that this is a distributed architecture managed by Microsoft, and Microsoft has promised that capacity will be available. So just know that Azure platform itself has DDoS protection deployed in the platform itself, at really advanced DDoS protection by Microsoft themselves. And Microsoft is essentially responsible when it comes to this because it's fully managed. Okay, we're getting there. One of the other things that to note about this is when it comes to security, is that there's a new network security group requirement. What do we mean by that? What that means is, if I go back a bit, if this is the setup that I have, and I don't have network security group associated with these backend instances, the VM skill set of virtual machine, traffic will not get through. So this is the option in the standard on the basic load balancer. This is optional. You don't need, if you don't put a network security group, if you're using standard basic load balancer, essentially your virtual machine will just accept all the traffic by default. But in this case, it's the opposite now. So now you have to actually specifically whitelist the traffic that you want to allow, which means that you have to be careful to ensure that you have network security group associated with your backend nodes. Otherwise, traffic will not get to them. And I think I probably wanted to do a demo on this. So let's go over to the Azure portal. Hopefully this one works this time. Let's go back to the Azure portal. By the way, let me get back to my machine and see if what I wanted to show you is possible now. Probably not. So what I'll do is I'll just go ahead and let's go ahead and configure. Let's go to load balancer and I'll create my pool, my probes to distribute traffic to my backend. So if I had a new pool, I'll call this my web pool. My virtual network, I have my two virtual machines there. I select virtual machine 1, I select this IP configuration, web server 1. Select web server 2 and I select this IP configuration and then I go ahead and add that. So that's gonna go ahead and add this pool. So Microsoft says, actually, should we try this? Let's do a stopwatch. Let's do a stopwatch, let's time it. Microsoft says 30 seconds or less. So probably late with this one. We'll do it for the next one. Wepo C. Oh, I wonder. Because I started this late, it's probably 30 seconds already. Yeah, it's 30 seconds already. We'll do that for the next one. This is over 30 seconds already. So deployment still in progress for the web pool. So once that's done, I'll configure the ELD probe. Oh, done now. Okay, so let's go ahead and configure the ELD probe now. And I'll call this my web probe. Use HTTP port 80, leave the default, and go ahead and click OK to that. And that will create the probe. And then once the probe is created, I can create my load balancing rule to say load balance port 80 across these two pools of virtual machines that I have in the backend. So that's where I'm going. Load balancing rules. Let's go ahead and add and I'll call this web load balance rule. That's my front end. I'll leave port 80 to backend port 80 to my pool of virtual machines using that probe. So this is where we can specify the algorithm that's used to distribute traffic or the session persistence. If I want it to use an hash of the source IP and the protocol, I can select that. If I want it to have even more stickiness, I can just use source IP to ensure more stickiness. In this case, I will just use source IP. That's good. Idle timeout is essentially what we can define to say if no TCP flow traffic is received on this existing flow, do you want me to terminate the flow or not? So by default, that's 4 minutes, which is 4 times 60, which is 240 seconds. So we can adjust it if we wanted to keep TCP flows more alive if we wanted to. But typically, I think the default should be okay for that. And floating IP is beyond the scope of this. We'll talk about those in some other series that we'll be doing. So if I go ahead and click OK to that, load balancing rules, that will create a new load balancing rule. And let's see. Yeah, there we go. So now that we have this, if I go ahead and go to overview and get the public IP address of my load balancer, if I run that, yeah, and now I'm talking to web server 01, that's where it's taking me to. So I'm connecting to that. So what I want to show you is that if I go to web server 01 now on the virtual machine of web server 1, and on the web server 1, if I decide to go on the networking, and if I go to the network security group that I've associated with this, and if I go, no, I don't want network security group associated with this, and if I set that to none, and if I save that, I'll need to do it on the second one also in order for this to work. So why this is applying this, I'll go over to my other web server, which is web server 2. And then if I go on the networking, on the network interface, and if I disable or disassociate the network security group from this. So once I disable that, and then what will happen is, if I go back here, if I refresh, let's close. So that's, yeah, takes a while. Don't worry. Remember what we said about when you say, yeah, it's submitted, it's successful. That doesn't actually mean that it's it's applied. What that means is that I've successfully submitted the job. I think it's taking effect now. So let's run that again and let's see. Now you see that I'm not able to get to my server anymore. So you can see that it's pinning and going. I can't get to it. And the reason for that is actually very simple and very straightforward. It's what we mentioned here, which is the load balancer will only allow traffic the network security group explicitly allows. If you don't have a network security group here to explicitly allow the traffic, the load balancer will not allow that flow. So it's a new requirement that we didn't have in the old one. So now we're getting towards the end. Let's move on quickly. So now we have new monitoring and analytics when it comes to this new standard load balancer that we didn't have in the other one. So I'll just show you some of the much more important ones. I won't actually go into details because of time. I think we have to move very quickly. Like we have traffic counters that we can use to look at um, the amount of bytes and the packets that we've actually received through the load balancer to see how busy it is. We can see inbound connection attempts, the TCP scenes that are coming in. Remember that the flow just goes through this. It's not actually doing any acknowledgement. We can actually see the output. What's the out status of my backend instances, for example? How do I know? Is a node going up and down? How do I detect that? We can detect that with that, and I'll show some quick demo of that. What about the data plane health? Is a virtual hype is the path between the Azure Fabric to whatever host that is hosting our backend instances. Is that data path good? Azure monitors that for us, and then we can view the reports of that on this monitoring options that we have. And then the source NAT connections, which we talked about. Again, remember that this is limited. If you have a single IP address associated with your public load balancer that loads balancing traffic across 100 VMs, and they're doing outbound traffic, remember that the number of ports that they have to be able to do port address translation for outbound is limited. So you can use SOTNAT connections to look at it and see, am I overextending myself? Do I need to add additional public IP addresses and other stuff? Um, Especially this outbound one is a very important one. So as you can see, mitigation is reuse connection, which involves you may need to talk to your application guys to redesign their applications to reuse connection so that it's not opening connections anyhow, or assign public IP address directly to the VM if you wanted to. That will override that limitation of they're all sharing the public IP address of the load balancer. I think there's a demo that I wanted to show with this one. I'll just show you where to get that. I won't actually go into more details because of time. So if I want to see that, if I go on the load balances, and if I select my load balancer, ensure you select the right load balancer, and then go on the metrics preview. On the metrics preview, you can see here you have your load balancer selected. Here are all the different data analytics that we talked about. So for example, if I wanted to see the source NAT connection count, I can click on that. I can say show me the count. I can say show me the count in the last 30 minutes and apply that, and it's going to show me the that's 5k that's gone down to like, so that's source NAT connection, outbound connections that are going on. And then see, remember that they're limited, and I can actually filter that um, for a particular backend address if I wanted to. So if I do deep address and I want to filter that, so for this particular machine instance, how many outbound connection has it tried to make? So in the past 30 minutes, it started from about 2.5k and it's gone down. So you can see what they're actually using individually. If I wanted to see another metric like the VIP availability, that will tell me the health probe. And if I want to see the average of the health probe of whatever my instance is, if I go VIP address, sorry, not VIP. I wanted dynamic IP. Sorry, not VIP. And you can see that's the for my health probe. You can see the status. So there's the current status is 100%. If I shut that machine down, it will start going down, and then I can specify for which one I want to check, for which one of my backend nodes. I can see what the health probe report is going to give me that. So this is where we can check some of this reports. And then we can actually use REST API to pull all this information into another third-party tool if we wanted to. But that's where we do that from. Let's move on very, very quickly now because of time to cover all the other things that we want to cover. So what about costs? So these are one of the interesting parts with the standard load balancer. When it comes to it, it does have a cost associated with it. The basic load balancer is free. Do you hear that? The basic load balancer is free. It has limitations, but it's free. The standard load balancer is not free. The standard load balancer, you can see there are two main things that you pay for. Number one is you pay for the amount of load balancing rules that you have. The first 5 rules has a higher cost. The next rules have a lower cost. So for example, the first 5 rules, you pay 0.019 pound per hour. For additional rules, you pay that. But you're paying that for hour per rule that you have. So that means if you can reduce the number of rules that you have on your standard load balancer, that will help your cost. If you're using NAT rules, those are free. But data that also processed, that's also paid for per gigabyte. So it's important to know that. But the basic load balancer, none of this is charged. They are free, but it has limitations. So ensure that you really, really do need the functionalities of the standard load balancer because it has a cost associated with it. Let's move on quickly. In terms of limitations, there are limitations of the number of load balancers that we can have in per region, per subscription. So 100 default, 1000 maximum. Number of rules that we can have in the standard, which is what we're talking about, we can have up to 1250. Whoa, that would be a lot of money. But if you need to, you can. A maximum limit is 1500 if you reach out to Microsoft support. Front-end IP configurations. How many IP addresses can you add? Especially we're talking about public IP addresses that you can add. Also, when you're talking about a public load balancer, you can add up to 10 by default. If you want to, you can reach out to Microsoft support and they can increase that to 600 for you. What about the backend pool? How many virtual machines that you can have in the backend? 1000, and single virtual network is the limit. No longer availability set. HA ports, there's one per internal front end. That's the limit that you can have, and that cannot be increased. So it's important to know those limitations. And in terms of support or SLAs, load balance endpoint using Azure Standard Load Balancer, 2 or more LD virtual machine instances will be available 99.99% of the time. So that's Microsoft SLA for this resource. 99.99% availability if your backend endpoints are healthy. So remember, that's why I mentioned down below. Downtime does not include the minutes when your backend endpoints are unhealthy. So we can go to Microsoft and say, my backend endpoints are unhealthy. I need service credit. That's not the way it works. As long as your backend endpoints are healthy, right? And it's not as if you've run out of source NAT port, you've run into a source NAT port exhaustion issue, something that has to do with your own configuration. As long as it's not that, as long as it is, my services are healthy, I have enough ports available for me to use for hardband connectivity, but traffic is not getting to my backend instances, Microsoft, it's down to your load balancer. Microsoft has a 99.99% SLA that backs that. For the basic, there's no SLA. The only SLA that you get with the basic is if you're using the basic with other resources. You can get SLAs based on other resources, but not specifically for the basic load balancer itself. So because of time here, I think I'll skip a bunch of this. Let's move on. I'll move on past a bunch of this because of time, because I think we should round up now. Okay, what are the takeaways that we have for this particular discussion that we've had? Understand these differences. The standard load balancer, we can have up to 1000 backend instances. We can have either, we can configure it either as zone redundant front end, or we can give it a specific zone of front end by specifying the standard IP to a particular zone if you wanted to. In terms of virtual machine instances, the basic is limited to virtual machines in a single availability set. This one you can have single. The limit is it's limited to a single virtual network, so you cannot load balance across virtual networks. But this can extend to blend of virtual machines, availability set, virtual machine scale set. It doesn't matter. You can load balance across them. Integrated front end with backend health metrics. So we saw some of the metrics now. It has a lot of good metrics that we can pull and get to understand what's going on with our resource. It supports HA port for network virtual appliance. Network security group is required. It's charged, it's not free, which the basic is. Let's move on. Multiple front ends with Peru opt-out for outbound connection. So if you wanted to increase the outbound connections or NAT ports that's available, or the ports that are available for outbound connections, you can add multiple front end, and those can be used for outbound connections. We can actually specify that within a ham template and say, allow this to be used. Multiple front end for both inbound and outbound connections. Most operations will take less than 30 seconds, and then 99.9% SLA, whereas the basic, there's implicit SLA for the virtual machine, not for the load balancer itself. Okay, that brings us to the very end of this. Any questions at all? So Jitesh says, do we set up anything for the zones, or does Microsoft do it? Yes, we have to. So for the zone, it depends on how you configure your standard IP address, because you can give it a zonal front end or you can make it zone redundant. So if you specify and make it zone redundant, it will create a data path that uses a single IP address but that extend across the entire zone. So that's the answer to that. So you do have some configuration to do in that sense. Any other questions at all? Yeah, no other questions. Okay, thanks very much for joining us for this particular Azure Deep Dive session. I'll announce another one that I'll probably do next week. I'm still thinking on the topic to do. If you have a particular topic that you're interested in, feel free to share that with me on LinkedIn, on Twitter. My Twitter handle is at Asegunlolu, which is ASEGUNLOLU at Yahoo. Sorry, ASEGUNLOLU. So that's my Twitter handle. So if there's no other questions, which it doesn't seem as if there's any other question, I think we'll call it a day and we'll see you next time. Thanks for joining.